En las películas sí nos predatan como por 60 o 70 años.
Y eso no obliga a una academia.
Estamos en lugar viendo películas de los 1950.
From limitless resources, unharnessed in nature, but controlled and directed by the inventiveness of men in science, electricity becomes a tremendous power that is easily transmitted over vast stretches of land and brought right to our fingertips. The flick of a switch, and wheels turn. Lights blaze in a variety of uses and colors. Distant voices are brought together. Trains move. Food is cooked. The world lives by it, and men dream about it, wondering what new tricks can be played with it.
Those were pretty big sparks you just saw. Many volts of man-made lightning, yet basically they are no different from a small battery spark. I'll show you what I mean.
La película del Army también.
This is an experiment that you've probably done with an ordinary pocket comb. You've rubbed it and found that it picked up small pieces of paper. Now, why did this happen? You were probably told that the comb became electrified, and until we get the rest of the story, you can take my word, it did become electrified.
But sir, these are things electricity can do. Just what is electricity itself?
Well, that's something I wish I could tell you. But so far, science only knows what it does and the laws that govern its action. No one knows exactly what it is. But to gain some understanding of it, we can start by studying the composition of matter. What is matter? Why are things as they are? Men have trained their telescopes on the faraway planets and stars, pried into the small, strange world invisible to the naked eye, and found that matter is everything. The earth is matter. So is steel, and coal, and smoke, even a single breath of air, and water. But what is water? Suppose a single drop were divided into smaller and smaller and smaller droplets until it's reduced to its smallest indivisible particle. The smallest particle into which any substance can be divided and still maintain its original identity is called a molecule. Of course, water is quite visible, but the molecule is so minute that it can't be seen even with the most powerful microscope. By observation and mathematical computation, science has worked out this schematic diagram to show what a molecule of water may possibly look like if it could be photographed. The water molecule can be broken down still further into smaller particles called atoms. The individual atoms are quite different from the whole water molecule and do not have in themselves the characteristics of the original water. Chemical analysis has definitely shown that water consists of 2 parts of hydrogen to 1 of oxygen. Hydrogen is made up of atoms that are all alike, and so is oxygen. Hydrogen and oxygen are therefore called elements. They are individual chemicals with their own specific characteristics. Some other elements, that is, chemicals with only one kind of atom, are, for example, copper, iron, carbon, lead. There are just a few of the 92 elements which are the basic chemicals in all matter.
If there are only 92 elements, sir, does that mean that all matter is composed of combinations of these elements?
That's right. When 2 or more elements are combined, they form a new substance,
Vogliamo
which we
come
call a
sette
compound.
Ad esempio,
For example, 2 hydrogen atoms plus 1 oxygen yields the compound we know as water. Another familiar compound, table salt, chemically known as sodium chloride, is made up of 1 sodium and 1 chlorine atom. So, the backbone or core of all matter, then, are these minute, invisible particles, the atoms.
Here lies the key to the mystery of electricity, the explanation of why motors run and lamps light. So let's stop the action of one of these atoms, theoretically of course, to see what makes it tick. We use hydrogen as our guinea pig since its structure is simple and it's basically the same as all other atoms. It has a kernel or nucleus where a plus charge of electricity, known as a proton, is concentrated, and a single negative charge outside of the nucleus, which is the electron. The proton carries almost all of the mass of the atom and remains rock-like in the center, while the electron whirls around it in a circular or elliptical orbit. The system is very much like the sun and a planet. This whirling negative charge is the tiniest unit of electrical energy we know. Other atoms are more complicated. It's the number of electrons that makes the various elements differ from one another. In a normal state, the number of electrons is exactly equal to the number of protons. The nucleus always contains all of the protons along with some electrons. The remaining electrons move in orbits outside of the nucleus. For example, the nucleus of the carbon atom has 6 more protons than electrons. Therefore, there are 6 electrons outside of its nucleus. In the iron atom, the nucleus has 26 more protons, so that there are 26 external electrons moving in their orbits.
but if some outside force disturbs the equilibrium in any material, there's a gain or a loss of electrons, depending on the character of the material. This can be shown by this simple experiment. In this action, electrons are passed from the fur onto the rubber rod, giving the rod a negative charge. These charges are in turn passed on to two neutral bodies. Now they should repel each other.
Why does this happen?
Because like charges repel and unlike charges attract. Now I'll neutralize one of the bodies. With this glass rod and a piece of silk, the electrons are passed from the rod onto the silk, giving the rod a positive charge. Now the electrons pass from the body onto the rod, giving the body a positive charge. Now we have one positive and one negative, and they should attract each other. Thus, static electricity is a condition resulting from a displacement of electrons. Here we have a machine that can build up much larger static charges than the one you've just seen. Turn out those lights.
Billions of electrons cause these sparks.
However, the nearest we can get to a visual picture of electricity is through these vacuum discharge tubes. In this tube, you can see the path of the electrons. The stream can be attracted by the magnet. Turn the lights on. In this tube, you will see that electricity is actually an energy flow of particles. When the circuit is closed, the electrons bombard the paddles and the wheel turns. This is a theoretical picture of electricity that science has built up through its investigation of the electronic structure of matter. It's the story of some of the facts about the nature of electricity.
From these facts, we have learned that electrical charges are the core of all matter, and that the movement of negative charges, or electrons, is what we know as electrical energy.